Today our group will present about nuclear fusion and fission hybrid reactors. This technology combines nuclear fusion and nuclear fission to produce energy more efficiently and sustainably. What is fusion-fission hybrid reactors? How does it work? A fusion-fission hybrid reactor is a nuclear reactor system that combines both fusion and fission reactions in one system. In the fusion section, hydrogen isotopes combine together and release high-energy neutrons. These neutrons are then used to trigger fission reaction in surrounding nuclear fuels such as uranium and thorium. The fission reaction releases additional heat energy which can then be converted into electricity. So, why we choose this topic and its relevant to modern physics? Our group chose this topic because fusion-fission hybrid reactors are an advanced and innovative energy technology that may help solve future energy problems. This topic is also strongly related to modern physics because it involves concepts such as nuclear reaction, plasma physics, quantum physics, and also instant mass energy equivalence principle.
Now I will explain the methodology used to gather information for this presentation on nuclear fusion and fission hybrid reactors. So first, literature review by referring to physics textbook, scientific journal, research paper, and educational articles. So this also helps to understand the basic concept of nuclear fusion and nuclear fission as well as how hybrid reactors work. So next is internet research using reliable sources such as the International Atomic Energy Agency and the World Nuclear Association. So this source to obtain updated information about reactor technology, safety system, and environmental impact and future development in nuclear energy. So then comparative analysis. This to compare conventional nuclear reactors with fusion-fission hybrid reactors. Through this comparison, we were able to identify different in efficiency, fuel usage, radioactive waste production, and overall sustainability. Lastly is collecting the information. So all the data was compiled and verified by checking multiple references to ensure the facts were accurate and scientifically reliable.
We move to challenge encountered. While preparing this presentation, we encountered several challenges. First, the topic is quite complex because it combines two advanced nuclear processes, namely fusion and fission. Understanding how these two systems work together required extensive research. Second, since fusion-fission hybrid reactors are still under development, there is limited information and few real-world examples available.
Now, I will talk about the proposed solution for the challenges encountered. The first one is simplifying complex scientific concepts. To better understand advanced topics such as nuclear fusion, nuclear fission, plasma physics, and neutron interaction, it is important to begin with fundamental concepts before moving on to more advanced materials. Educational videos, introductory textbooks, and simplified scientific articles can provide a strong foundation. Additionally, using diagrams, flowcharts, and visual representation can make complex processes easier to understand and explain. The second one is expanding research sources and references. Since fusion-fission hybrid reactors are still under development, information can be limited and scattered across different sources. This challenge can be addressed by consulting a variety of references, including recent scientific journals, conference papers, government reports, and publications from research institutions.
What is nuclear fusion? Nuclear fusion is the process where two light atomic nuclei combine to form a heavier nucleus, releasing a huge amount of energy. It's the same process that powers the sun and other stars.
I will explain two real-world examples of nuclear fusion and fission hybrid reactors research. The first example is from China. China is actively developing hybrid technology reactors technology through organizations such as the China National Nuclear Cooperation and the Chinese Academy of Science. One important project is the China Fusion Engineering Test Reactor. So this project is designed to study how fusion and fission can work together in one reactor system. So in this reactor, the fusion core produces high-energy neutrons. These neutrons are then used to trigger fission reaction in the surrounding blanket material. The second example is the ITER organization. So a project located in France. So ITER is mainly a fusion research reactor, but its technology is very important for the future development of hybrid reactors. Scientists use ITER to study plasma's confinement, fusion reaction, and advanced reactor materials. The knowledge gained from ITER can help engineers design safer and more efficient fusion-fission hybrid reactors in the future.
Next, I will explain the advantages and disadvantages of nuclear fusion-fission hybrid reactors. So first, these reactors can produce a large amount of energy. Hybrid reactors combine both fusion and fission process, so they can generate more energy compared to the conventional reactors. So fusion releases extremely high energy, while fission maintains stable power production. So this makes hybrid reactors very efficient for future electricity generation. Second, they produce less radioactive waste. So compared to traditional fission reactors, hybrid reactors can produce the amount of long-life radioactive waste. Some nuclear waste from fission can even be reused as fuel in the hybrid systems, making waste management safer and more efficient. Third, they have a lower carbon emission, so hybrid reactors do not burn fossil fuel like coal or oil. Therefore, they release very little carbon dioxide into the atmosphere. This helps reduce global warming and support cleaner energy production. So lastly, they have higher fuel availability. Fusion uses isotopes such as deuterium, so which can be obtained from seawater and is widely available at the same time. So this fission part can use recycled nuclear material. So this means fuel resource can last much longer than fossil fuels. However, there are also have several disadvantages. So first, technology is very expensive. Building a hybrid reactors require advanced materials, powerful magnet and high temperature system. So the research, construction and operation costs are extremely high, so making it difficult for many countries to develop this technology. Second, the reactor design is very complex. So since the system combines both fusion and fission reaction, the reactor structures become more complicated. Scientists and engineers must carefully control temperature, radiation and safety system to ensure stable operation. So third is maintenance is difficult. So the reactor's components are exposed to intense heat and radiation, which can damage material over time. So repair and maintenance require special equipment.
This slide explains the basic concept of nuclear fusion fission hybrid reactor. First, fusion reactions produce high energy neutrons. These neutrons act as the main neutron source in the reactor system. Next, the neutrons interact with surrounding fission fuel such as uranium or thorium. This interaction triggers fission reaction, which release additional energy and increase the overall power output of the reactor. By combining fusion and fission process, the reactor can generate more energy to utilize fuel more efficiently compared to conventional fusion reactors. Another important advantage is waste management. Hybrid reactors are designed to reduce long-lived radioactive waste through transportation while benefiting from the strengths of both fusion and fission technologies. This slide highlights the major advancements and controversies associated with hybrid reactors. On the advancement side, significant progress has been made in plasma confinement and magnetic confinement technologies, which are essential for sustaining fusion reactions. The development of advanced superconducting magnets has also improved reactor performance and stability. In addition, hybrid reactors offer improved fuel efficiency and energy production. They also have the potential to reduce nuclear waste through transportation and may serve as an important transition technology toward future pure fusion power plants. However, there are several challenges and controversies. Hybrid reactors require very high construction and operational costs, making them expensive to develop and maintain. Their reactor design is also highly complex and presents significant engineering challenges. Although they produce less waste than traditional reactors, radioactive waste is still generated.
These are some examples potential carriers related to nuclear fusion fission hybrid reactors, such as reactor and nuclear engineering, physics and research, energy and environmental fields, advanced technology and computing, industry and government. These are the skills needed to excel in these careers, such as strong mathematics, physics knowledge, engineering skills, computer and programming skills, research and analytic skills, critical thinking, attention to detail, and lastly, communication skills.
Now, I will talk about the challenges in this career and strategies to overcome it. The first challenge is rapid technological development. Nuclear fusion technology is evolving quickly. New discoveries, reactor designs, and computational methods emerge regularly, making existing knowledge outdated. Strategy to overcome this, we need to attend conferences, seminars, and professional development programs. Join professional organizations related to nuclear science. So the benefit that we get is remaining competitive and knowledgeable in a rapidly changing field. Secondly, complex scientific and technical knowledge. Fusion-fission hybrid reactors involve advanced topics such as nuclear physics, thermodynamics, material science, and reactor engineering. The concepts are often highly mathematical and require continuous learning. To overcome this, we need to build a strong foundation in mathematics, physics, and engineering during university studies. Other than that, read scientific journals and stay updated with new research findings. The benefit we get is improved technical competence and ability to solve complex engineering problems. The third challenge is high competition for research position. Many fusion-related careers, especially research positions, are highly competitive because opportunities are limited and require specialized expertise. Strategy to overcome this issue is pursue postgraduate studies such as Masters or PhD, gain research experience through internship or university projects, and develop both technical and communication skills. So the benefit is enhanced employability and greater opportunities for career advancements. The fourth one is radiation safety and health risks. Professionals working in nuclear facilities may be exposed to radiation if proper safety procedures are not followed. To overcome this issue, we need to strictly follow radiation protection protocols, wear protective equipment, and use radiation monitoring devices and adhere to exposure limits. The benefit we get is maintaining personal safety and ensuring a safe working environment. Next, funding and budget constraints. Fusion research requires expensive facilities, equipment, and experiments. Funding limitations can delay projects and reduce research opportunities. To overcome this challenge, we need to collaborate with international research organizations, seek funding from government, agencies, universities, and private industries, and prioritize efficient resource management. The benefit is increased access to research opportunities and project continuity. The last one is multidisciplinary teamwork requirements. Fusion-fission hybrid reactor projects involve physicists, engineers, computer scientists, material scientists, and safety experts. Communication barrier may arise between different disciplines. To overcome this, we need to develop strong communication and teamwork skills, learn basic concepts from related disciplines, and participate actively in collaborative projects. The benefit we get is more effective teamwork and successful project outcomes.
In conclusion, nuclear fusion fission hybrid reactors are a promising future energy technology because they combine the strengths of fusion and fission to produce large amounts of cleaner and more efficient energy. Although the energy is still being developed, it could help reduce pollution in the future.